Good evening, everyone. Shall we wait for some time so that people can join?
Yes, sir.
Okay. So, yeah, I have started.
Yeah, around 4,200 will come. What would
Okay, fine. Just book it.
you ask me what you want to ask?
Yeah, sure. Good evening, everyone. Let's see how many people have joined. Somewhere on 30, 11. Shall we start? Anyone, please respond. My voice is audible to everyone.
Good evening, sir. Your voice is clear.
Okay. Thank you. Shall we start the session?
Yes.
Okay. My name is Muhammad Azid Raza. My name is Muhammad Azid Raza, and I'll be taking the session, live session for NPTEL course, Biostatistics and Design of Experiment. Hopefully, that all of you went through that week one lecture, or anyone is there that who doesn't went through the whole lecture. Anyone is there that who didn't went through the lecture? Please switch off your mic if you don't have licked out. So hopefully, I will assume like everyone went through the first week lecture. So based upon that, whatever the first week lecture, we'll be taking that live session and we'll be solving some question. And based upon that first week, whatever the doubt or anything you'll be having, you can ask me. Okay. So what is the agenda will be there? So first, I'll be introducing like the course about that. This is the week one. Then we'll go through that about the course. Then we'll deal that then we'll discuss about the course is that instructor. Then we'll deal with that discuss with about myself, and then after we'll see the course outline, and then after we will see like some basic brief I will give before starting the session. Okay, so this is that live session week 1 for the biostatistic and design of experiment. Okay, so my name is Mohammad Azad Raza and I am PMRF scholar in Department of Mechanical Engineering from Trichapalli, and that course is handled by that Professor Mukesh Doble, Department of Biotechnology, IIT Madras. So this course is of that 8 week, that is elective course, and that course is intended for that undergraduate and postgraduate, those who are working in the field of bioengineering and then biostatistic, or either we can say those who are having that some sort of interest in the statistic part. Okay, so this course will deal about how we can design the experiment when you are when you're going for any experiment or anything. So like first we have to plan that how to conduct the experiment so that we can get the best possible data. Then after once we design the experiment, so that we are going to execute whatever the plan we have done, so we will get some sort of data. So how we can analyze the data in the field of bioengineering, if that data is relevant to some another field, so that will directly say statistic. If that data is related to the IT, then it will again it will that we can solve or either we can analyze the data. We have different techniques are there, but for this course, like we are dealing about like biological science and bioengineering. So can anyone please tell like what are your background that you are doing the courses, like that you are from the biochemical or biomechanical or something? Anyone please? So that
Sir, we
this
are
session will
doing in pharmacy.
okay, pharmacy. Then any further?
So BTech Biotechnology.
Okay, BTech biotechnology.
Sir, I am a doctor, gynecologist. I want to do research, so I have joined biostatistics.
Okay, thank you, ma'am. Anyone?
Sir, I am a research scholar in biotechnology.
Okay, which college?
Avinash Lingam Institute of Home Science from Coimbatore, Tamil Nadu.
Okay, okay. Anyone? One more or two more? We can then
From
we'll go.
MSc Biotech,
Which college and where are you from?
St. Xavier's College, Mumbai.
Okay. So this course will all deal about like a statistic part in the field of bioengineering and then that biotechnology. Or either we can say this course can be intended for those who are doing basic statistics, that if anyone doesn't have also, anyone have raised the that hand, that is that Anupam Upadhyay.
Sir, just I want to do introduction.
Okay, okay,
It's okay, sir. I continue, sir.
okay. Just 1 minute. So you all might be knowing that the course registration is free. Okay, course registration is free. But if you want to get the certificate, so for that you have to register for the exam. So this is actually a 8 week course, and if you want to get the certificate for the same, so you have to register for the NPTEL exam, and that exam will be the online mode. And based upon the credential that based upon the assignment you will submit it every week, and the final exam, you will be getting the certificate in different category, like some gold category or either silver medalist and all these things. So hopefully that you will be all knowing that the policies of that all that NPTEL exam. So if we say that the intended audience, so we can say UG PG program, and even that research scholar can do these courses. Like they are working in the field of biotechnology and then clinical trials and then agriculture, etc. Okay, so what are the prerequisites for the course? That is the basics of probability and statistics. Even though throughout the courses, the sir will be discussing before starting the actual topic, sir will discuss the basic probability and statistic part also. So, what are the industry support that this course is having? That is a biopharma and then agriculture, fishery, and then biotechnology company. That not the specific name of the company, but these are the companies that they are offering support for this particular course. Okay, so we will like I will say some word about like that the professor that is dealing the course. The professor name that Professor Mukesh Doble. He is professor in the Department of Biotechnology and Bioengineering, IIT Madras, and he had previously worked in the Imperial Chemical Industry and General Electric for the 20 years. And sir, area of research are biomaterial, biopolymers, and drug design. And till now, sir have published more than 270 papers and then 10 books and almost more than 10 patents, including the two US. And sir have delivered several online courses as NPTEL, or we can say, and some other premier institute also. So this is all about the course instructor, and you might have before joining the course, you might have went through the sir profile also. So I will I will tell about myself. I am the PMRF scholar, that Prime Minister Research Fellow. Anyone have the idea like what is the PMRF? If anyone is not from the IITs and something, so anyone have the idea what is the PMRF actually? Have you heard earlier? Like this session will be like we can have the two-way interaction. We will uh, initially we will discuss something, and then we'll whatever doubt you will be having, you can ask.
This is started very recently, it seems like 3-4 years, if I remember. This is a new format of fellowship. Earlier, we had only DBT, UGC, CSIR, and all.
Yeah.
And this PMRF is paying, I think, better than other fellowship, I think, amount. So, and also it is like based on engineering, especially. I think they are supporting this.
Okay. Yeah, actually, this PMRF stands for Prime Minister Research Fellow. As of now, this is the highest fellowship that in India you can get it. And their scheme, like their motivation was to create the research ecosystem in India so that the brain drain and that thing can be stopped, and then the research scholar can motivate and can do the innovation in the field of research. And this scheme, especially for the engineering and then sciences, basic science, we can say physics, chemistry, even the maths are also there, and then all the engineering branch. And this PMRF, they are giving only to the selected institute, like all the IITs and all the IISER and then IIC Bangalore, and only one NIT, that is the NIT Trichy, and some of the top central universities like JNU, and we can say Central University of Rajasthan, I think so, and some Aligarh and Jamia. So there are things like they have certain that norms they are giving to the particular institute that any general person cannot apply for this fellowship. Yeah, their process is different from that other fellowship like that we are getting in the general. Okay, if I'm speed little bit, so you can tell like I can slow down or something. If you're not able to like get my voice or tone, so I will slow down or something. Okay, that this voice is okay, na?
Sir.
Or the speed is okay?
Yes, sir.
Yes, sir. Yes, sir.
Okay,
Perfect
fine.
speed.
Okay, thank you. Okay, so this is only intended for that all that top tier institute and some of that so top central universities, and they have their own selection criteria. If I will open that PMRF website,
Mm.
so we can see that all the IITs and then all the IISc are there, and some of the top central university and only one NIT, they are those who are that offering the science and then technology degree. Okay, so in that, if we say this is the guideline, so they have two type of entries. That is the one is the direct entry channel, and second one is will be the lateral entry channel. So in the direct entry channel, those who are doing their masters and then PhD all together from the centrally funded institute like NITs and IITs and central university, so they can apply and they are doing the PhD in the that college that they are offering the PMRF, so they can apply for the direct entry channel. Okay, the one who didn't have done their masters in that centrally funded institute, or they have done some other than NITs or IITs or centrally funded institute, so but now they are doing the PhD in that IIT or NIT, those who are offering the PMRF, so they can apply for the lateral entry channel. Lateral entry you can apply twice. It's like a that you can apply like whether you have done the coursework, that 4 coursework you have to do, that depends upon the institute, that how much coursework you need to do. You can apply for, that twice maximum, until that you can complete the 14 months of your PhD. Once you've done more than 14 months of the PhD, so you are not eligible to apply. So it's like a, if you have done the 14 month or either before that, you can apply twice. In the direct entry, you can also that also apply in the first year itself or in the second, like till that time you can apply. So this is like guideline. Again, the selection process from the institute will be the different. In the some colleges, it will be like a three level. Like first will be the departmental scrutiny. The second will be going like institute level scrutiny. Then it will go to the nodal level. Nodal level, that is a national level, that any national that nodal coordinator, they are handling the PMRF all these things. Okay, so this is some like in that, like once the departmental scrutiny will done, so that department will going to nominate you for the institute level. Then institute level, there will be some bit upon the your proposal, credential, and all these things. They will be taking interview and presentation. Then after, they will going to evaluate your performances and then proposal and all the things. They will nominate you for the what we can say national level. Then after, finally that national level, they are going to evaluate all the things, and then they're going to select you whether you are selected or not. Okay, so this is the three stage generally is happening, but at some institute it will be some different. So that depends upon the institute to institute. So once you are getting some handsome or tag or either fellowship also, so there is some certain conditions and then some like deliverable we need to do. So those who are selected for the PMRF, so they have to mandatorily do the 50-hour TA work outside of that parent institute. Parent institute, the scholar, they are doing their that PhD that institute, like that I am doing PhD from that in Trichy. So I can't do the TA duty in the in Trichy. Other than in Trichy, I have to go outside. That can be any colleges like ITI, Polytechnic, or engineering college, or school, or NPTEL. So I have to go and then do the 50-hour in a year, or either that in a week I have to do 1 hour, or in a month I have to do the 4 hour. Okay, so means I have to take the TA, like that can be a क्या कहते हैं, workshop, or that can be a like lecture, or either that can be a intro session or that interaction session that can be done. So if we say that what are the mode that can be done, that is offline mode or online mode. So that we can do that offline mode, that is preferable, but if not feasible, so that we can do that online mode. So, and then PMRF fellows are also like they can do their TA duty in the NPTEL also. Okay. So this is all about the deliverable, that whatever the TA duty they will get in their own parent institute. So they have to do the outside also. So what are the fellowship that they are giving? So fellowship, it will like if you join in the first year, so you will get some 70,000. Then second year also you will get same. If you come to third year, 75, and then 80. And then apart from that fellowship, you will be getting, you are going to get grant of some 2 lakh rupees per year for your research purposes. Okay. For as of now, for engineering degree, they have given the payment of tenure of 3 years, and for science background, so they have given the some 4-year tenure. So this is all about the PMRF. Okay, we'll go to the slides. Okay, so that is all PMRF. That is all about the PMRF. And actually, I have done my BTech from RGPV Bhopal, and then soon after, like 1 year gap, I have joined my for my master in machine design background from College of Engineering Trivandrum in 2022. Then soon after completing my MTech, so I have joined that the PhD at NIT Trichapalli in Department of Mechanical Engineering. Currently, I am working in field of sports biomechanics. So that's why the course that I'm taking, or why, because it's relevant to my research area. So I'm dealing about muscle physiology and then sports performance analysis and then sports biomechanics. So we will be having bunch of data and we have to deal with the statistic. So that is all about my research of area. But in my master, I have done the project based upon the fluid structure interaction. That the problem actually related with some sort of blood or vein problem. Like fluid structure, that fluid we are saying the blood, and then structure we are saying like a vein. So when the blood is flowing, so how till now we were saying, okay, due to the blood flowing, how much the pressure generating of that force is happening. But once we consider both, due to the blood, some sort of force will going to act on vein. So that vein is going to also apply the some force on the blood. So it's like a coupled vein. So how that if we're taking some only one effect, so some result will be different. If we consider both, that blood or vein problem, so their effect will be different. So that is the that structure interaction that came uh, recently into the picture, or it's trending, like you can say, because of that biotechnology problem or that medical people they're dealing with that. And even though if you are going with that some sort of a jet problem or either pipe that flowing fluids and all the things, so that there will be some, again it will come into the picture. So based upon my master work, I have published one journal and then one conference that I have presented at that IIT Guwahati, and then conference that journal paper already published with in that Springer, that is Journal of in that Institution of Engineer India, and that is RISC. You can go through my that Google Scholar profile. You can see my profile also. If anyone has a doubt or anything like throughout the course, they can write the mail. That is the what you can say. That is a NITT mail that I'm using. That I'll be hopefully I will reply whenever I will get any mail. Okay. So this is all about me. Then after we'll see the outline of the course. Hopefully you have all seen about like what are the things that will go in the week 1 and then week 2, then week 3, then week 4, then week 5, then week 6. So in the first week it will be starting from the introduction, and then first part like just to introduce design strategy. Okay. Then after we'll deal with the what are the data types that is available. Then we'll deal about the binomial distribution. That you might have went through all the lectures also. Then Poisson and then normal distribution. Based upon that, you'll be having the quiz that you need to attend or you need to solve and then that submit before the deadline. So based upon
Yeah,
this, okay.
uh, the study material, any kind of that will be provided for this course content, or what? Or else we have
Whatever the
to go through some other books. Yeah.
some books I will be saying, and then that whatever the PPTs are there, that will be uploaded through the NPTEL profile only. So this PPT will be available online. I will be shared whatever
And
the
about
question I'll be solving.
Okay, and that is good thing. And one more thing, apart from the assignments you are giving, do we can also get some kind of practice papers online? Like if you can provide some practice sessions like online, if
Okay,
you give
if
some
you want,
yeah.
I will give some. I will prepare and then I will upload the same drive folder. You can
Yeah,
get it.
that would be helpful, because before going to assignment, if we have some practice on that, we can do better in the assignment, because there we have some marks criteria. If we get that much, that many marks, then only we are eligible, and then to get a certificate and also they all are counted.
Okay,
So
fine.
it would be good if you, yeah,
I will do one thing. I will be
yeah.
putting like what are the books that will be useful for this course. Okay,
Mm-hmm.
that book
Okay.
name I will be saying, and then second part, this PPT will be available online. I will
Okay.
be keeping this as a web, and then if you want to go through the again the video, so this video will be also available on the YouTube channel. And
Mm-hmm.
if there is a specific need or like you want, then I will make some practice question and then I'll put in the same PPT or either same drive folder. Okay.
Okay. Yeah, yeah. Sure. Thanks.
Anyone having any other doubt, you can ask. Yeah.
Sir, I just have a doubt.
Yeah.
Sir, actually, I am a biotechnology student. I am currently pursuing my bachelor's degree second year.
Okay.
So, can I actually, inherit learnings from this course, or is it easy? Meaning, is it related to biotechnology? Like, can I actually easily grasp the concepts?
Actually, this course
Actually,
is
this course,
like this course is designed for all actually. Whether your branch biotechnology or something. So if you have to do some experiment, you have to deal with the data. Let's say in the biotechnology, you are going to deal with some sort of drug trial or either clinical trial. So you'll have that having the data. So that can be this course will be very helpful. So that will obviously this course will be helpful for you. Yes, Angana or
Okay, sir. Thank you.
Hi, sir. Just wanted to know, sir, when is the last date till which we can apply for the register for the exam because the course is still going on.
I think this is 29th of January.
Okay, but we have to finish the modules before that because it is not.
Yeah, you can, but I think assignment deadline are like 2nd or I think 7th of February is there. If you might have registered for the course, you have seen the deadline also. So if you have joined with 29, so you have some time, you can go to the video and then you can submit the assignment till 7. Just confirm with that whether that is 2nd or 7th. I'm not sure.
Okay, thank you, sir.
Anyone? Any anyone? Okay, so we'll go ahead. I will show you like biostatistic and design of experiments. So their deadline will also I'll show you. Yeah. Just 1 minute. I will stop screening. Just 1 minute. Huh? Okay, we'll leave this thing. I think this will be your 7th of February is there, so that I need to go through that. Okay. So in the module 2, it will be that a continuation from that normal distribution. Whether my mic is audible, that voice is audible. Okay.
Yes.
Yeah, yeah. I'll go to that. So in the second week, we'll go standard that standardized normal distribution, then t distribution. These are all that statistic that can be used in what we can say in the any field. That can be either IT field if someone is dealing with the machine learning, or either that bunch of data they are having, so they can use it also, or in the field of biotechnology or that biomedical also. And then what are the t test? And then t test will be there, F test, and different types of the ANOVA, that analysis of the variance we are saying that ANOVA. Then I will test the checking the normality test, whether that data is the normal distributed or not, or either some different types of distributions are there. So what are that we have like experimental design strategy. So this was all introductory part in the first that week. Then that will be that fully explained in the that from the week 6, and then it will go ahead with the week 7, and then week 8. So in the design of experiment, so we can't simply hypothetically design any experiment. So we need to follow some sort of protocol, might be, or either we have to follow some standard or anything. So that we can get the data that should be a best possible weighted data. So there is some factorial designs are there. So don't worry that you have to go through the courses this module or lecture in the 7th week. So there is another design that we are saying full factorial design. This is a just brief. I'm giving that outline of the course, like how the course will that is going to span over the 8 week. Okay, so you can be mentally prepared if someone is not sure like whether I should go for the course or not. So that is the course content that it will be there. So that content, so more or less it will be useful for all those who are in the biomedical or either medical field, or even in that someone in the general science or engineering field also, because nothing that is dealing with specifically any of the medical or either any of the technicality regarding the any specific field like mechanical or either electrical or anything. So it's a more or less introductory course in the field of biostatistics. If you have some specific that the problem and all these things, so you can like for that particular problems will be there, like if you want to deal with some machine learning problem, or that what we can say what we can say you have to deal with some that what we can say you want to do some that expectation test or anything, or either you want to do the prediction. So for that we have some machine learning techniques are there, so that we can do. So that's again specific fields are there. This test or either this course content is generally for the generally open for the all. Then after some of the other designs that is all that is existing but not popular. So that design also will discuss in the module 8, and then after second order design, then we'll finally deal about the regression analysis control chart. Can anyone tell what is the statistic? Just read the sentence and then anything you want to that explain the thing. What do you mean when someone is saying statistic? Please, anyone?
So
Yeah, please.
interpretation from data analysis, simplifying it is the basic concept of statistics. It is like to conclude something from analyzing the data.
Okay. Anyone? Any other?
It's the science of accumulating a large number of data and then to store them uh, in a systematic way and to analyze and to make a interference, statistical interference, and to use in the practical field.
Okay. Yeah, actually means statistic when we are saying whatever the bunch of data we are having available, so that we want to show in a some like so that that can be easily interpret or easily understandable and that understandable. Let's say we have that bunch of data, but if we give the data to any other unknown person, so we can't they can't able to retrieve that what you get the feature or extraction that anything they can't retrieve. If you are giving in a some that data form like that presentation or graph something some analysis, or if you're giving some quantitatively you are giving like in terms of math, or either qualitatively in terms of like you are giving the picture and all the thing. So this is the process that we are following, so that process we are saying the statistic. Okay, any doubt is there? Like it's some sort of like we are going to represent the data we are having in a like good manner so that people can understand easily even though they are not from the same field. Okay, is it okay?
Yeah.
Ma'am, Dr. Shruti Vidya, ma'am, you have any doubt? Like raise hand.
Yeah, I was going to the this assignment just to
Okay,
look at the questions that were there,
okay,
and I really got confused. I'm quite senior, actually. I'm a pharmacologist, so I have already studied a little bit of statistics, but I want really to
apply.
uh, learn in depth of biostatistics. Therefore, I
Okay,
took up this course. But I really met with, I was surprised to look at the questions. I was really surprised, and I really started getting confused with what I learned. So
okay,
I have lot of questions based on the week one assignment, and
okay,
today I looked at week two assignment, and again I got confused. Maybe we can discuss it at some later date. To tell you simply one question that if anybody can guide me on this
okay,
is
okay,
the question. I think question number two only is. To
okay,
it was I think six numbers were given, and mode was asked, and it has 13 numbers featured twice, and 14 1 4 twice.
okay.
And
Mm-hmm.
I really got confused with how I can find this mode, because 13 is twice, 14 is twice. No other number is coming either thrice or more than that frequency. So both numbers are coming twice. So even 13 is correct for me, 14 is correct. So
Okay.
what answer is correct? So I really got confused with that.
Okay, ma'am. We will discuss that all the part, and then what is your queries will be that we will also discuss. First, we'll go through that like based upon that your courses like I'll be detailing some question. That even though like even after that we'll not able to like you're not able to grasp it. So we will do well like I will that take the question personally and then I will send it to you. Okay. Is it okay?
Yeah, sure. With also, I would request to give either some book references or some website references, because when we Google, a huge number of website comes, and we are clearly confused with which website or with which URL we should go about.
Yeah, sure, ma'am. Next week I will like not next week only. I will be giving some books for today also, like book reference. For website, I will look after and then I will put in the PPT itself so that you can go through that for that that what you can say. You don't have to go anywhere.
Sure, thank you.
Okay. And we will discuss some questions. We have some around 10 questions are there, and based upon that, if you're even if you, that even though if you're not able to solve, then we'll go ahead with we'll take your question and then we'll solve it. Okay.
Oh, sure.
Okay. Any other person having doubt? Can you please tell me? Someone was
In
saying
this
something.
live session, on this live session, we are going to also discuss the assignment questions, right? Like zero week and also week one, whatever is given so far. And also, I think today they have shared the week two assignment as well.
Okay. Once that there is that will deadline will over, you can ask. But as of now, we'll have some questions that we will discuss, or anyone that anything doubt that we will discuss also.
Okay.
Okay. Any other? Anything? we'll go ahead because it's already at 6:40, so we'll have 1.5 hours again more. Okay, so and that statistical like the data we are expressing that in terms of mathematical like quantitatively and then graphical like qualitatively. So it's a like we are compiling in a or tabulating in the forms of that mathematical or graphical terms. Like what we can say in the quantitative way, that we are saying if any two data are there, how much differences from the one data to different data, or either if graphicals, we are saying by seeing the product or by seeing the drugs or anything, we are saying whether that the product or drugs whether the test which is fail or pass. Okay. So what is a biostatistic? Biostatistic is like a whenever we are concerned with like mathematical fact and that is related with the biological event. That biological event can be anything. That can be a clinical trial, or that can be a that drug, or that can be a like ecology, or either that can be a like pharmacy or medicines also. Okay. Can anyone tell what is the difference between the variable and attribute? Variable and attribute.
Attribute is a quality.
That cannot be
Variable is a
scaled on the
measurable.
numerical. Okay, that attribute is a quality that cannot be measured on some scale like numbers, and the variable that can be measured on the scale or in terms of numericals. Okay, and then when we are talking about the what you can say constant variable like quantity that does not vary. So actually you might have knowing all the things already. This is just brief I am giving the before starting the question and answer. So that constant, the quantity that does not vary, like in if we say in the biostatistic there is a mean standard deviation, or then the that whatever the population we are taking for a particular population, that will be the constant all the time. Either that is a mean or standard deviation. If we say about the variable characteristic, that different value for the different person or places or things, like some people will be having some different height or some different weight, maybe some person will be having more weight, some will be having less weight. Okay, or blood pressure also we can say. Can you anyone tell like what are the application of a statistic? Don't just say that briefly, what is the field that can apply biostatistic we can say, what are the application?
Pharmacy department and in biotechnology, and especially during clinical trials, and especially when we are formulating a new drug, it will be very useful.
Yeah. If I'll say like medicine, pharmacy that you have already told, public health science also, like if any diseases that is spreading, so what is the rate of that spreading the diseases, that also we can say public health science. Even in the agricultural field also that we can say, and fishery again it will comes into the bioengineering itself. And then ecology or ecological forecasting we can say, like when we're saying like harvesting also, or what you can say that forecasting we are also saying that's also coming under the statistic part only. And then biological sequence analysis. And if someone is from that some medicine or doctor, so they'll be doing is how the DNA sequence or GNM sequence that is propagating once when we're doing some any sort of reactions or something. Okay, so in even in that also we can apply the statistic. So what are that the field particular, so that field we are saying biostatistic. Okay. Okay, so then population genetics also we can say in the field of that is the application of biostatistic only. Okay, so uh, when we say about the biostatistic, you might have went to the lecture, you have seen like what are that parameter that is going to involved in that biostatistic. So first will be the analysis of the data from the experiment. So for getting the data, for getting or retrieving the data, you need to do the experiment. That experiment might be in terms of that you're doing the physical experiment, or either you're doing the survey. Okay, so data collection can be a any way. That might be a like what we can say survey that we are doing for like some person is doing in the field of psychology, that or either that's something. So they'll be taking they'll be having some questionnaire, they'll be circulating some sort of Google form or something, and then they'll be taking the data. So again that is data. And if you say some other like if you're doing the in hand or either on hand. So it's a clinical trial. Okay, clinical trials means they have to do like if we have some drugs that we are administrating on some people, so that will be the like person of interest. Then after we'll have in the control group also. Then we'll do the experiment. Like then we'll check the whether we have administered this particular drug. So how much difference came? That is the one that control group we have. Okay. So then after we will see the qualitatively what are the that conclusion we can draw from the data we have taken from the experiment, whether we are able to conclude anything or not. If not so, then we have to see like okay, so we have to do the further analysis like distribution of the data, whether data is the what you can say discrete data or either continuous data we have. Once we'll decide the data, okay, that data we are having that is the discrete or either what you can say that we are having the control data. So we will decide the sample size. Okay. Once we'll decide the sample size, so we'll go for the test of size that is a significance. What is the thing like we want to assume or either what is the confidence level we have to do. Then we'll do the data reduction, like we have to remove some artifact or either noise if the data in the form of signal. So that we have to remove some signals from that because it will be like some noise will be there. If we take that drug or something, so that we have to take like one or two trial we have to take, then we have to do whether the data came good or not, or either the experiment was done properly or not. So we have to do the data reduction. That might be a like reduction is also like a classification of the data in terms of different. Let's say we have some that taken population sample. We want to that administer the data that drug A to particular 10 people only, and then drug B should be go to the that 10 people only, and then drug C it will say again we are doing the data reduction. So it's like that process we call classification. Okay. Then after we'll do the regression analysis. Like regression analysis, I'll say in the simple terms, if one term is increasing this side, so what is the effect on the second terms, that is y-axis. So if that is coming close to the one, like their slope is one, so we can say okay that we are getting some good interpretation from that. So again, don't worry too much. Once you will go to the lecture closely, once you finish that statistical part, though you will get the advanced version of this statistic. So you will get to know that what are the regression analysis or either how you can compare or how you can do the data performance that comparison. Okay. Then after performance of the class, then that are the things. Once you will do the regression analysis, then you will see okay whatever the experiment we have done, whether that is true or not. Then based upon that we will going to conclude anything. Okay. We'll go to the next part, like what are the parameter.
Asjad
Yeah,
Raja, can you
yeah,
repeat the sequence once again to note down like yeah.
yeah, sure. The first step will be like to analysis of the data from experiment, and
Yeah.
second will be the interpretation or either conclusion from the data itself that is existing, whether in the qualitative way, like whether we are able to draw any conclusion from the data that is the raw data or not. If not, so then we'll go to third. That is third step, like in the distribution of the data. So whether
Distribution
the
of
data,
data. Okay.
yeah, that data, that distribution of data will come in the picture, like whether data is continuous or discrete. Once we
Okay.
get to know that, once we get to know that, though we can define the sample size. Okay, for this particular experiment, how much the sample size should be there. So that will comes again under the design of experiment.
Mm-hmm.
Then based upon the data we are having or sample size, we will go for the test of significance. That will T test, F test, that F test or C2 test, whatever test that will come that will be coming in the coming week.
Okay.
Then after data reduction, and then finally we'll do the some regression analysis, and then we'll draw the finally conclusion based upon that.
Okay.
Okay. So parameter, can someone can please tell what is the parameter? Like how you can differentiate from what you can say variable and attribute. You might, if you read the sentence, you will get to know or get to know understanding. It's like a variable, and that constant is like some sort of we can control it. We can say like a variable that will be changing, that constant that will not changing, but the parameter is like a whether the person or either we have the population. So in that population, whether the male or female or woman or men, or that can be, we can say the age group, like age group from the 15 20 20 to 24, 24 to some 30. So that is a parameter. Okay. So this describe the population. Sorry, ma'am. Sorry, I can't hear your voice clearly.
Hello.
Yeah,
Hello,
yeah,
can you hear?
yeah.
Hello?
Now,
Yeah. It's isn't it the value of anything? Like say for example, a boy or boys or girls or height or weight in that particular population. When you define for that population that constant whatever that comes, that becomes the parameter.
yes,
That
ma'am.
value
Yes, ma'am.
becomes parameter.
Yes, ma'am. Yes, ma'am. So why that statistic can be required? So it's like we are doing the that is the investigation, and based upon that we are doing some judgment for the that is situation. So variability in the measurement can be handled using the statistic. Earlier, what we if I will speak about that how that statistic comes into the picture from that we can say from the last 60 or 70 years. So not I will not speak that much. If you say like earlier, what you to do like whenever the any product we have made, so by seeing the thing, like by seeing the specification, whether they have made the standard, if that does not meet the standard, so we'll say okay, that product failed. But the once that the concept earlier that we can do the testing when we have the number of sample size will be the less, maybe some 5 or 6 or 10. Let's say we have to do some mass production. Volume of the mass production means it's got increased. Let's say I want to make one mobile, but that is in number of like lakh and crore. So we can't do the testing individually. Okay, so we have to take some sample from the that is a population. So population will be the number of all mobiles like 1 lakh or 1 crore. We'll take some sample like 4 or 5 or either 10. That depends upon the that is a standard that is that has been set. Then we'll do the sampling test, and then based upon that we'll say okay whether that product is going to fail or pass. Okay, so it's again a variability in the measurement can be handled using the statistic. Let's say that investigator making observation according to his judgment of the situations. Can anyone tell like epidemiology? What is that?
Uh,
It's a
Study
yeah,
of
it's a type of disease. It's a type of science where the disease which are spreaded epidemically, means widely contagious type of disease, that is actually studied in this type of science.
yeah. And if you say about like epidemiology, it's like just any event that is happening with respect to that is happening to the population, but with respect to place and time and then situations. It's more or less that is the event is happening. So it's like a epidemiology, like it's a group of population that is going to affected with at a place, at times, or situations. That's what we are saying, like epidemiology. I think that is correct, now, sir.
Exactly. Like the corona was a pandemic, and
Yeah, yeah,
epidemic we can say like earlier cholera we used to see cholera was an epidemic. Like malaria can be a epidemic, but
yeah,
when it is a
yeah,
huge different country, then it is a pandemic.
yeah,
Similar thing.
yeah. It's a more or less similar only. Okay, so that is that epidemiology, and then if you say biostatistics, so it's again we don't have to think about the population or something, but we have what are the things that can be reduced that maybe if that pandemic or epidemiology, so that can be a like a factor. We are taking a drug and then clinical trial, and then we can consider data. even though that can be done on that pandemic and all the things also, but their significance will be like in terms of that we can do anything that can affect that all pandemic and all the things. So we can get the significance of the particular that product or object. So it's both are like a quantitative methodology, like it's not the qualitative. When we are speaking about the anything, so it's again a quantitative. So that's going to be based upon the fact figure. And we can't simply say that that is happening in the pandemic or it's happening is that epidemiology. Okay, so we have to say in terms of some quantitative. So how much the people or population got affected with that. So this will again comes into picture in the biostatistic. Okay, so this is fully quantitative way. So we can't say in the qualitative. So use of the biostatistic, just give me 1 minute. I'll put that laptop on charge. Okay, sorry for interruption. So what are the uses of biostatistic that I already told some steps and all the things. So first will if we go through the line itself, the test whether the difference between the two population is real or by chance by occurrence. So it's again like when we're taking a two, we're going to drug that administrated the drug in the population, whether that the difference is coming whether that is real or it's coming by chance or either it's a coincidence. So that we can check to the different types of test, or either we can check the correlation between the attributes in the same population itself. Okay, so that's also can be done. This thing once you will go through the full module, so then you will get to know that how that can be correlated between the attribute in the same population, and then to evaluate the efficacy of the vaccine, to measure the mortality and then morbidity, to evaluate the achievement of the public health program. Again, if any government or the government have planned anything or either any that hospital have planned anything, so that any health program, so what are that their achievement. So by taking the survey of the data or either when that OPT is also is happening, so we can see the how many numbers of people are coming for the OPT, whether the numbers are increasing or it got decreasing. What are the feedback we are getting from that patient itself, either in terms of that orally we will say speaking some sort of that questionnaire will be there, or either we are circulating those some Google forms. So that can be also evaluated by using the biostatistic. Okay. Then after based upon that we have done the evaluation, so we can fix the priority in the public health program also. Okay. Then after by using of the biostatistic, so we can promote health legislation and then create administrative standards for the oral health also. So let's say we have some cheat sheet or something will be there on that some hospital. So how that coming? So it's all about the feedback or either any nutritionist or either the people they are doing. So they have taken this thing consideration. They are doing the testing and then efficacy of this product or anything. Then they will get the cheat sheet. Okay, if someone is having some problems, so how they can remedies or either whether they need that particular people required to go to the hospital, or that can they can do by their own self by using that homemade that stuff that is like whenever we are speaking about the health, so they'll be again like if the person is like a self that medicated or like like they're following if someone has cough, so we don't need to roll it really to go to what we can say hospital. We can okay we can get some that hot or warm water and then we can okay for it up. Okay, still we are not able to that finalize or either we still not able to cope it out, so okay we'll go to the health and all the things like doctor and all the things. So this is how that can define. Okay, if you say about that some symptoms we are saying. Okay, if let's say we have some TB diseases, there are some malaria diseases, are there some that diabetes and then health related issues are there. So if you say so some symptoms, some people will don't know like what are symptoms. If you say about the urban area, those who are having like they have the access of all the facilities, so they can they can get to know through that TV media or either that newspaper and all the thing. If we say about the remote area, so what will happening there? Like they don't have the ability to access all the technological advancement. So that can be done through maybe through the radio and all the things that is available. So we can then after we can we'll say these are the symptoms if someone is having. So might be they'll be having some diabetes issue, so they can come and check. If some person is having some issues like let's take a example, in eye some watering or some red is coming, so these are symptoms, so please go and consult the doctor. In the same way, we can say about the other diseases also. So it's like a to help promote the health legislation and create the administrative standards for the oral health also. So it will start from the people, those who are affecting maybe the urban area, that those who are having that access to all the facilities, or second that we are doing some campaign in that remote area to promote the health legislation or either health awareness we can say. So that can be done. And then also at the administrative level, what are the report coming from that the promotion or either the evaluation of the health program. So again, we can set for the administrative level also, or either the management level also. So these are the things that can be used in the biostatistics. Biostatistics is not all about the one link you can use in the drug trial or clinical trial or anything. Yeah, I told like this course is totally basic course. You can apply in any field. There is nothing like you can apply in the biostatistics only. If you grasp the concept, you can apply to the any field. So when we say about the statistics, the first step will be the collection of data. Okay, the collective recording or observation, or either that can be a numerical, or either it will be the what you can say orally, that again we are taking. That data can be collected through the like population size, distribution of the data, geographical distribution, or ethnic group. These are some groups that, or either we can say parameters are there. Then after socio-economic factor and their trends over the time. Then after with some data we are taking from that what you can say public service report or either census. So there are some methods that we are collecting the data. Depending upon the nature of the variable, data is classified into, I already told, in the qualitative we say attributes and the quality. So in that it will be like discrete or continuous. Then we'll say quantitative data, that through measurement or through measurement using the caliper or like any numerical method. So we'll say that source of statistical data, that I told like how you can collect the data. That will first is the experiment you are doing by hand, like doing some person is doing the research, so they might be doing that how you are collecting data from the experiment. If some person is doing some fields like they can't do the experiment something, so they are doing the survey. So that survey can be done in the any field. So if we talk about the carried out in the epidemiological studies in the field of trained team to find the incidence or prevalence of the health or disease in a community. So it's again a survey process. So it's how this is happening. So we'll take some sort of a questionnaire will be there. That is going to be that in a village or in a city, and we'll go door to door campaign. We'll do the survey. Okay, that let's say the particular disease is happened in the last 2 months or 3 months, or either how, but the symptoms that is the symptoms were there. This we are saying the survey. So this is the one method that we can do the door to door. The another way that we can that circulate the Google form, and then we'll ask the question. Then after records, if you're saying like the government will be having, or either that registrar we are saying like they'll be having data from the last 100 year or 150 or either 70 year. So based upon that, we'll see in the last 5 years which disease came into the new disease, and what are the existing disease, how that is affecting the peoples and all the things. So it's again based upon the records itself. Let's say shall we do now, this is all about that the brief intro I gave till now for that before starting the session, that is a question answer session. If anyone have the doubt, please ask.
So
Same here.
apart from this one, and uh, let also have a discussion on DOE also, how it is applicable there. Like apart from this clinical trial and all, like surveys and all,
Okay,
DOE also is a very important. Yeah.
yeah, sure. That thing, shall we DOE will discuss in the last week, because That DOI all parts will come in 7th or 8th module. If you're okay with that, otherwise I'll take some brief and then I will try to whatever the doubt you will be having. So I will discuss.
Yeah, no problem. Yeah, you can brief now, and later only we will discuss on.
Okay, fine. Anyone? Any other doubt?
What is discrete and continuous culture? Because
Dis discrete is like whenever you will say like discrete data and like if you have that you are saying binomial data like you have some population of 10 and from that you are taking some 2 or 3. Okay, so it's like we have in the we can calculate in the number itself. If we talk about that point in normal distribution or either geometric distribution, that is going to spread over, that is going to vary with the time or either that is going to vary with the time or something. So that is going to be continuously. Like a discrete, we have some sort of group of dead data, okay, and then from that we are taking some sort of. But in the continuous, it's like it's not like we have the fixed number, but that is going to vary with the some sort of parameter itself.
To be short, discrete is like a specific value, and continuous is like different values in a range.
Yeah, sure. It's like a not we are saying like a 1 to 3. It's like it will going to be if it's a minus 2 to 2, so it's going to vary with some sort of distribution. Anyone? Any other doubt?
Sample size and all next in the next session you will discuss, no? Like how to fix the sample size and all.
Yeah. This will be comes into the design of experiment only.
Okay.
If you might have went through the lecture, like in the initial lecture, it was there already. Maybe some sir might have discussed itself,
Yeah. He briefed actually. So
and sir might have told you like that thing will going to discuss in like last 7th or 8th week.
no, because in assignment I have seen one question related to this sample size. What will be the sample size? So I don't know how to solve it. Okay, maybe from
Okay,
lectures I
fine.
will
Got
come
it.
to know.
For next session, this point I will note it down, and then I will discuss in the next live session. Okay.
Okay. Yeah.
Anyone, please? Anyone? Okay. So shall we start?
You know why we do this regression analysis? Like why is it required? Data
Let's say
reduction. Yeah.
if you say like you have collected the data, that data reduction is like you have collected data, like missiles data you have collected. It's in form of the signal. But once you are
Hmm.
doing the experiment or something, so what's happening? It's not pure, what you can say, the vacuums are all the thing. If some sort of noise will be there, maybe the environmental noise, some sound noise, something will be there. So that we need to remove it out. So that's what we are saying, the data reduction we are doing. Or either to remove some unwanted stuff, or either maybe we can say if we are able to remove the unwanted, so that's what we are saying. Okay, that we have done the some filtering and all the things. If we say data reduction, we have the bunch of data. Whether we will be able to classify in from some, let's say under the data was some 100 data.
Mhm.
Sorry, 1 minute.
Yes, filtering is related to like decreasing the reproducible data, or is it like that, or what? Like if suppose I have two values
Mm-hmm,
occurring in I've collected suppose I have 10 values, okay, and
mm-hmm,
in 10 values I have three values which are repeating.
mm-hmm.
So in data filtering, we are reducing those values, or is it like that?
No.
Like how does that reproducibility of data getting secured? That point is getting secured in terms of reduction.
Reduction when we are saying like we have, let's say we have 100 samples of data. Okay, by the things like we are not able to do anything. But the thing, if we are able to qualify, let's say that all data is 100 data, but that is consists of three drugs: drug A, drug B, drug C. Okay, drug A, drug B, drug C. Okay, so if we able to classify the data, drug A it's a 34, or either drug B is the 30, or either the drug C is the remaining. So this is how. So now the data become three. So it from the 100 data it got reduced to 34, 30, and then whatever the remaining data. So it's a data reduction. So it's like we have just classified in a different group. If we said filtering and all these things, let's say some sort of that unwanted noise will be at the back. If we have the reproducibility, like if we are able to reproduce the data, so very good. Actually, if you're doing the experiment, so it's we are not common. We'll think okay, we are able to reproduce. So like filtering, what we are doing, let's say we are doing low pass filtering to remove the upper that a higher frequency noise. Okay, and some sort of that high frequency that filtering we are doing to remove the what we can say low frequency noise. Why did that? If I told na, whenever we are doing the experiments, so we are not in the but in a perfect chamber or anything, so that we can't. So some sort of environmental noise will be there. Sometimes that noise will be maybe from that high that frequency noise, or maybe that is that low frequency noise. Okay, so that part we are removing. That is the unwanted part. And we know whenever we are taking the experiment, so we have to define the sampling frequency also. Like we are going to take the consider data from 10 hertz to some 1600. So we are going to remove all the data below the 10 hertz, or either we are going to remove all the data from that above of 1600.
Okay, sir, got it, got it. Thank you.
Okay. So is it like that? Anyone have the doubt? Next, shall we go ahead?
Yeah, yeah.
Okay, we'll go ahead. So first question is that if drug A has 80% of success and drug B has 65% of success, and both the drugs are given to a patient, what is the probability of the both drug failing in the percentage? What is that? Drug A success is given like that is a 18 that is a 80% to a patient. Drug B, that is 65% success. This is the individual drug that was given to patient, so their success percentage is given. Okay, if 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 both the drugs are given to a patient, what is the probability that both the drug is going to fail? Anyone have the doubt like question anyone they're not able to understand the question?
I have doubt because we in this case I think we can apply binomial distribution, but
Yeah.
we provided with two different probabilities of drug A has different probability of success 0.8 and drug B has different probability of 0.65 success. So
Yeah.
how can we calculate the binomial distribution that if both drugs are falling? So that means they are asking for the uh, K0, and that means there is no success. But how can we calculate with the different probabilities?
Okay, we'll solve. This is don't go with the any distribution. Solve simple probability basic question. That
Okay,
simple
thank
probability
you, sir.
question. Let's say we have the drug. We'll go through. Let's say drug A success is given 80%. Okay, drug B success is given 65%. So what we have to that to find out the probability the both the drugs will be failing for a patient when the both drug was administered to a that what we can say patient. So what will happen? So for that, if you say that is the probability of drug A success, so what will be that 0.8. Okay, it is a 80%. So this is your probability of the drug A success. If you say what is the that is success of drug A. If you say what is the drug failure, so what is the one minus? So what about the probability of that is a probability of drug A success. So what will be there? One minus it's the 0.8. So what will be there? 0.2. So it's like a probability of a drug A failure. So this is your okay. Now second, what we know that what is the success rate? Okay, we know that. So how we can get the probability of drug B failure? So for that, what will be there? 1 minus what about the probability of drug success? Okay, what is that? 1 minus 0.65. What is that? 0.35. So now we all know that what is the like individual failing if a drug is given to the patient. Now, what we want to know that we want to know that if we are going to give the both if we are going to give the both drug, so what is that probability of that failing? So what will that probability of both the drug failing? What is that? It will be like that is a probability of drug A failing multiply because we are administrated both of drug and then probability of drug B fail. What is that? 0.2 into 0.35. So what will the 0.07 percentage? So a final answer will be 7%. So means when the both of the drug is given to the patient, so what is the chance that that is the drug is going to fail? So that is a 7%. Okay. Anyone have the doubt? Like it's a
Thank you,
some
sir.
simple, it's a simple basic
Thank you,
probability
sir.
question. We don't have to think about the distribution of
About
that.
binomial distribution. Okay,
Yeah,
okay,
yeah, we
sir.
don't have to
Thank
think
you.
about it. So the same thing I have written in terms of that one. Let's say to the next one. Next question. Can anyone read and then try to understand like what the question is asking?
They are conducting a
We are
clinical trial.
conducting.
Uh, Sir, they are conducting a clinical trial for anti-cancer drug. In addition to the test group, they are asking which group should be present.
Yeah, yeah.
So they are asking whether there should be placebo group or control group only, and there should be a control and placebo group, and there should not be any control group.
Okay.
So I
So
think
it's like
the answer can be with control and placebo group. Both must be there during clinical trials.
okay. Yeah. Whenever we are talking about that any clinical trial for any drug, so following group should be the present. It should be like this is the mandatory. Let's say if you have done any trial or one group of person is not there, like test group that is going to who are given the drug, the control group that who are not given the drug. What is the significance that I will also explain? Don't worry. A placebo group. What is the if that placebo group? Anyone please tell? Anyone having some background from that some medicine field, so they might be knowing that.
Placebo group is the one where dummy medicine will be given.
Okay. Anyone, please?
Means plus similar to drug means patient means the drug is given, but there is no clinical value in that substance. Suppose sucrose or glucose is given,
Yeah, yeah.
patient is thinking I am taking the medicine, but actually it will not work.
Okay, okay. It's like more or less like we are taking as a dummy. That's a fine, but like we are we'll be taking all the trial all we're doing, but will not take the data in the but you can say data analysis or either to give any conclusion. Only we will take the conclusion that the data we are giving the test group and then the control group. Is it clear?
Ethically, these days, is it okay to have a placebo group? Neither
Um,
placebo nor control. In this case, we have to give a standard of care in this case. In case
uh,
of cancer chemotherapy, it is not at all allowed ethically, neither
um,
scientifically.
ma'am means
So
I'm
is
not
that
sure about
right?
this thing, but that I
No,
will
no,
see and
no,
then
not at
uh,
all, sir.
okay,
Not at
okay,
all. This question, therefore, I said I had so much of doubt that how I'm going to learn. I really,
okay, fine. That I will see this
we
part.
all essentially this question, this because of this because of this question and had anti-cancer this is not correct. In fact, if you put any other thing also,
Okay.
probably you would need a person who is having an expertise in that case and what is the current scenario of that particular disease. say for example, anti-diabetic, what is the current scenario about, say, metformin or whichever the drug is there in the market? What is it? That we have to see, and then only we can answer about this. I'm very sorry because this is what it is. I think Nisha, I agree with.
Yeah, ma'am. That
Absolutely, ma'am. We used to take positive control, negative control. So placebo is a big no for us. I belong to dental field. Again, in oral health also, it is like basic standard. It's like deprived. So we cannot do that. I mean, I don't want to be a placebo. So
okay,
Yeah,
ma'am. I can
placebo,
understand. Yeah.
control, standard of care, and the best care. See, these are very, very different thing. And when we are doing trials, there are different designs, and even it is not very easy to answer this question. And actually, therefore, when I looked at these questions, 10 questions, I found them so tough to answer. And then I realized that it is not easy, and I stopped there. And sir, please, just question to look at.
Okay, ma'am. This question I will be like, can you put that question in that forum? That is the one we have discussed forum is there. So might be that our faculty will look after. As of like we have some ethical committee in our colleges. Uh, okay. We have college, but they have some standard for that. But I don't know about the clinical trial and drug. That thing I will ask and then I will try to update you on that. And as of now, like we have the book and a standard, so it is mentioned. That's what we are some specific book that we are following, and might be
Hey,
it not.
to just to update that, this question cannot be so simply answered. The
Yes,
answer
ma'am.
would be changing, based on what is the scenario as of now. I know today is whatever is the scenario, whatever is, then only we can, it can change after, say, a few years down the line. So even then only it can be answered. So in my opinion, that should be removed, that question. Else you put the entire thing. But I guess it would be very difficult for others, like need we like since we are from medical background, we will be able to answer at least to some extent. But for others, it would be very, very difficult to understand what are the clinical trials, what is the role of control group, what is the standard of care, what is positive control, what is the best treatment for that condition. It's very difficult to understand.
Yes, ma'am. Yes, ma'am. I can understand, ma'am.
so can you tell the name of the book being followed?
That if I'll say the statistic, it's that I will just 1 minute. I will. Some books are the like that is a book named Probability and Statistic, like by Gupta. That book I was following, but for a specific biostatistic and design, it's in the starting of that lecture. It was there. I will just see, and then I will put in the chat box the name of the book. Okay.
Mr. Raja, what is your view from a, if I disconsider those that means technical specialities, what will be the answer of the question number 2 as per you?
As far as we went to the lecture, so that there should be a like control good group should be there, and then placebo should group should be there. Uh, as far as like we went to the lecture and all the thing, and we that I am working in some sort of a sports biomechanics, and that to dealing with that athletes of their muscles, that we have like doing the comparison method. We are not doing some clinical trial and all the things, so I'm not sure that because I'm not aware of this all ethical things, because ethical will change for the sports and ethical will change for the drug and that anti-cancer drug or any clinical trial. So that I will say according
Means
to
both,
that.
both control and placebo, both control and placebo.
Yeah. Should be there.
Nice.
Okay. And sir, I'm not the professor, and I'm a research scholar, and I'm taking the session, the live session, and then professor, that is a professor that Doble sir is there, and we can put them that all the query that is related with ethicals and then ethics, so we can discuss in what you can say discussion forum. So that question can be raised to that higher authority level, so that the professor they'll be knowing uh, more about the ethics regarding that one drug trial and then that clinical trials. Okay. This question I have noted down, and then surely I will put in the some discussion form, and then ma'am, Dr. Shruti ma'am, and then Sweta ma'am, that Nisha ma'am, you can also put that this question can be raised in the discussion forum, so that that can be discussion in that, so that all the people those who have registered, if anyone is that they can answer, or either that we will hoping the answer from the data professor. Okay, is it okay?
Yes, sir, sure. Yeah, please go.
Yes, sir.
Yeah, sure. So, whenever we are doing the clinical trial, that if they have mentioned the anti-cancer, so if that we are doing any clinical, so there should be a like test group should be there, and then there should be a control group for the group, and then a placebo group should be there. So, but the third question, anyone can see, like we are testing if a drug A is worse than drug B. Okay, which is the correct statement? You might have went like some lecture. You could have seen this that statement. That's it. Anyone can explain?
This is
Like
a HO hypothesis. Yeah.
So
yeah.
option D is correct.
Can you explain, ma'am?
So in this, they have given the statement about the null hypothesis and alternate hypothesis. In
Yeah.
case of H naught, they are saying that drug A and drug B both are efficient.
Okay.
Both are of same standards. But in case of alternate hypothesis, here they are asking that drug A is worse than drug B. So we think the third option will be correct because drug A is worse than the drug B.
Okay. Uh, it's like a drug A is worse than drug B.
Should be D.
The performance of
So how will you?
than drug B, like the efficiency will
Should
be.
be D,
It's
it
like we
should
have to
be
deal
D
with the
because
D
efficiency.
option, sir.
D option.
D should be right.
So
It's
D
like
Yeah,
the
and
option.
option
also
of
null
D.
hypothesis, every time we consider that the efficiency of both the drugs are same. It's a
Yeah.
state is non.
Yeah. That
But here
answer
they're
will
asking more about the worst thing, but not they're asking about the efficient one, right?
still we can say like when we'll speak of, we'll have to say like drug B is more efficient. We can't say like drug A is like so. It will be answer D will be
And
the
you
correct.
always measure the performance of a drug with its efficiency, like
Yeah.
how far it's efficient. So normally, if drug B is more than drug A, it naturally denotes the performance or efficiency of drug B.
Yes, ma'am.
So
So the
option
answer
D.
will be the D. Okay, so it's like whenever we are doing any hypothesis, so first we have to what we have to assume, like that in the first case we have to deal about like okay, first we have to assume that both of the drug should have same efficiency. First we will consider. So we'll say this is the null hypothesis. Okay. So in that like drug A efficiency should be like drug B. Okay. So it's again a efficiency. So what are the alternate efficiency? Whether drug B will be the better or either drug A will be the better. But in the question they told like drug A is worse means drug B will be the always better. Alternate hypothesis. So it's like a we'll say whether which drug or either which is the better. So based upon that we have to like control that. So it's like a drug A is worse. So means drug A is less than drug B their efficiency. So this is all about your the third question. Okay. Okay, so one more question is there from we have some probability question. Like just read the question, anyone can able to understand. Like just try whether we are able to get it or not. I will discuss. There is no worries about that, but if anyone able to get grasp it or not.
The probability of congenital heart disease is 1 by 10. So, and the question asked is, what is the probability that 3 persons in the family have that disease? So
And that
probability
family
is
having the
point
member
0.1.
of member having 12, family having member of 12. Sorry for that.
Number of 12. So we need to, it has been given probability point 0.1. The
Yeah.
success is K is given 3, up to
Mhm.
3, and the number, that means the observation N is equal to 12.
Yeah.
So if we put this value in graph-based calculator, we can get exact probability. Cumulative probability will be 97.4%. The answer will be.
No, we can't put, but it's like more or less that we have to say like the probability that 3% in a family having that disease means like we have a fixed number is there. So we have to apply the binomial distribution. Let's say given
So we have to select answer as an exact probability, or we should go for cumulative, because they are asking of 3 persons. So that
we
is
have
one of the criteria.
we have to go to the exact one.
Okay, so
If we go for the
thank you,
exact one,
sir.
then we have to apply the binomial distribution. If we want cumulative, then we have to say okay, number one, if the in the
I
family
think
if
we can use cumulative only when if it is mentioned what is the probability that at least 3 persons.
yeah, yes, ma'am.
The
So it's
word
like
at least is
Okay.
meant we should be going for cumulative.
Okay.
so it's a family of 12. Sorry for the typo. So what is that the terms are given like probability of a congenital heart disease. The probability disease is given 1 by 10, so means 0.1. What they're saying, what we have to find out, like we have to find out whether my handwritings are good, whether you are able to understand or not.
It's
What we have
It's
fine.
to,
okay. It's okay. Fine.
okay. So we have to find out probability that 3% in a family of 12 have that disease. So what the that formula we can use? F of k, like binomial distribution, n factorial, k factorial, n minus k factorial, p to the power k, 1 minus p to the power n minus k. Is it the formula is correct? Is it? It's a power. So k will be your number of event that we need to calculate. Okay, and then n will be the total number of event. If you say the worst case, like that this is can be a like can be happen to the whole family, so that will be total number of events. Okay, and p, that probability is given, probability of the happening of one event or one event. So but the case for that we have to find out for k is equal to 3, n is equal to 12, p is equal to 0.1. Shall I keep here like in the formula? So let's say if we have for 3%, so what will be there? Uh, Total number 12 factorial. What is the k? That we need to put 3. What is that n minus k? 12 minus 3 factorial into that was a that is a probability 0.1 and into 1 minus p, that we have 1 minus p 0.1, 0.9 to the power 12 minus 3. So what will get? Like 12 into 11 into 10 into 9 factorial, 3 factorial into 9 factorial, 0.1 to the power 3 into 0.9 to the power 9. Can anyone please calculate this one? Or shall I put direct answer for this? Anyone please? You are solving or shall I go ahead with this?
0.0852.
Yeah. 220 into 0.001 into 0.38742, and so that will answer will come 0.085232. Okay, so means if we that conclude, so we have to if they have asked the percentage, so we have to multiply with the 100. If not, so we have to just fill the like 0.085232. So it's like the probability that 3% in a family of 12 have that disease is 0.085, means it's like a 8.5%. Is it clear, this question?
Yes, sir.
Shall we go ahead?
Yes, sir. Yes.
Yes.
There is one more question is there. Can you please go through that?
Breast cancer has a mortality rate is equal to 12%.
Mm-hmm.
Drug is being tested for its cure. So what is the question is being asked that what is the minimum number of patients required to demonstrate the efficacy of completely curative drugs at 95% confidence?
Okay.
So here the mortality rate, that means it's 12%. So the survival rate will be 88%. So that is
88%.
basically
Yeah.
the pi.
Yeah.
The pi of survival will be 0.88.
Yeah.
Then the death rate is 1 minus pi. That is 1 minus 0.88. That will be 0.12 as it been given. So the confidence 95%. So it should
So
be
means,
less than 0.05
yeah.
for the minimum number of patients. So
Yeah.
the formula which we will apply is 0.88 raised to n should be less than 0.05.
0.05. Yeah.
And if we calculate this, so it will come around 23.43 something. So
Yeah. Yeah.
the minimum number of patients should be more than 24 to
Yeah.
demonstrate this mortality
It's
rate.
more or less like it's a mortality rate given, so we can know the survival rate. Hopefully, all could have understood. The ma'am, thank you, ma'am. That is the like that the correct. So this is all about we can speak. Like mortality rate is given. So mortality rate is given. So it's not the success of the drugs. It's like a that is what we can say survival rate. We can say it's like a drug only, but it's a survival rate. So it's a 88%. Okay. So hence means minimum number of patients required. So we have a one formula in what we can say uh, like in that statistic. Like if we are going to place a 0.88 to the power whatever the n we are saying, and then that should be less than 0.5. That's what ma'am told. So if we do apply this thing, if we apply the log and all the things, so we will get like log 0.05 and then log 0.88, and then finally the answer we will get 24, like 23.424, that 434, but we can approximate because it will be always a like number, like not the decimal number. Okay. Anyone have the doubt in that?
Why is this 0.05 taken like because of 95% confidence?
It's like we know that like we have chances that 95% of chance that that drug is going to succeed. It's always whenever we are saying anything like I told that I have one car. Okay, I told no,
Uh,
I want that should be like 20 years of life cycle. So we can't take directly like okay this is 100%. So whenever we'll do the sampling, that is the what we can say testing. So either we'll take 99% of chance, or either we'll take a 95%. Means we'll take level
mm,
of confidence. Always it's a in statistics, so we'll not go 100%. It's a always a null hypothesis. When we are saying it will be the 100% chance, it become a null in the statistic.
mhm.
So that's what we are not going never for, or either will not go ever like we'll go for the 100%. We'll always take some sort of confidence. Okay, 95% of time it will be always success, or either whatever we are saying that's true, but we'll take care of the 5% will be there, it will fail. So in that's how we can do the some testing or analysis. Okay.
Okay.
So this is
Yeah,
like
yeah.
when you will go the some statistic, or if you starting, so you will get to know that what is significance, why we are not going for the 100%, or why we are going for the some 99%, when we are going for the 9%, when we are going for the 95%. So if we take the T table or F table, if you see that is the one Fisher test will be there. Don't worry, this all test will come into the picture. So one Fisher test. So from that table we have to define, or either we have to see, okay, these are the things that is the parameter. So they have to go for the 99%. Either they will say in the question itself, or either we have to, if the question is not given how much that the confidence level can go, so automatically we have to go through the some sort of 95%, and then 5% we need to follow it up. If the question they have mentioned 99% and then 1%, so this thing based upon that we have to get the values.
So if
Okay.
it is given 99%, then we should take 0.01 there in that
Yeah.
case.
Yeah.
Okay.
It will be always if it is not given, like in the question itself, they have mentioned 9%, so it will be somewhere around this one. If the question they have mentioned 99%, so we'll go for the 0.1. If question not at all mentioned, so always we'll go for the 95% and 5%. Always.
Okay.
So we
Yes, sir.
have one. Yeah, tell me.
Sir, I'm sorry for interrupting. Can you go back to the back question, that is fifth question? Sir, you told 0.88 to the power of n, that I didn't understood the concept of it.
This is seems like when we're speaking about like uh, whatever the things. This is our survey. That is the survival of rate. This is survival rate. So
Yes, sir.
we want to know that how much the number should be there. So it will be always exponential, and that should be the value should be less than of 0.05. It's a basic math actually. This is nothing any distribution something. It's a basic math. We know that our that the failure or that a level of confidence that we have 0.05. So we can't go beyond of that. So it should be the less than of that. Whatever the number should come, it will be like this only. So that's why will go for the this 0.8 to the power n1. We can't go into n. Okay.
It's
Sir,
like for one patient, the survival percentage is like 88%.
Yeah.
Like probability is 0.88. So we are taking n patients. That n number we do not know. That is why we are taking it in power,
Yeah.
like
Yeah.
0.88 to the power n.
Yeah. Yeah. Is it clear?
yes, sir, it is clear. Thank you.
Okay. So there is one more question is there. Probability of a birth defect is 0.1. What is the probability that no one in the family of 10 people will have that birth defect? Use the Poisson distribution. It's like they have already mentioned that which distribution we have to use. Can anyone tell like what is the lambda and all these things? Hmm.
Lambda is equal to n and p.
N
So
into P.
lambda is equal to the probability is 0.1 and the p n is given 10 people. So
Yeah.
10 multiplied by 0.1. So lambda will be 1.
Yeah.
And it has been
Then it
asked
becomes
for no one in the family should have that birth defect. So we will use x as 0. So
yeah, x
and
is equal
we
to
will
0.
apply x is equal to 0. We will apply all this. The numbers will be applied in the formula. So in the end, we will have e raised to minus lambda, e raised to minus 1. So the answer will be 0.367. So the answer will be 36% probability that
Yeah.
no one in the family of 10 people have birth defect.
Yes, ma'am. That's correct. So can you please solve any like others people like, and then I will also start.
36%. 36%, no?
Yeah,
Hello?
0.3678. Yeah.
Yeah, yeah. 0.36 is the P
Yeah.
probability,
Yeah.
right?
Yeah. Yeah. So means we know that like a probability of a birth defect is equal to 0.1. Okay. So what we have to find out? Let's find out that no one in the family, no one in a family of 10 people will have that birth defect. Okay, so they have a specific rule. We have to use Poisson distribution. Okay, so we have to use the formula, this formula that is a lambda to the power x, a to the power minus lambda by x factorial. So what is the lambda? Lambda, we all know that in the Poisson distribution, n into p. So what is the n? That is 10. P is the p.1. So it become 1. What is the p? P is that is the probability. What is the n? N is the total number of event. So lambda become what we can say 1. So what is the probability? So f of 0 means there is no effect for lambda is equal to 1. What is the formula? It will become e to the power minus 1 into lambda to the power x. What is lambda? 1 to the power 0. What is the x factorial? What is the x? we have 0. So 0 factorial, we all know that that is a 1. So it will become e to the power minus 1. So 0.3678. So means if we write conclusion, so what is the probability that no one in a family of 10 people will have birth defect? How much? 37%. We can, if we that is a approximate if they have asked in terms of percentage. In this question, anyone have doubt? No, no.
Can we use a simplified formula of this?
Yeah, we can use. If
E
we're
raised,
getting the answer same,
yeah,
we can get directly. We can use it.
yeah.
Actually,
It gives the same answer. It gives the
yeah. We
same
can use.
answer like we use Euler constant.
Yeah. That we can use. Okay. Next question is there. Can anyone read or try to solve, like whether able to get it or not? What is the formula that we can use? Anyone have the idea in that?
So we can use lambda is equal to L plus or minus t to the square root to the power of L.
Yeah. Can you solve and then say the answer? Then I will solve.
Yes, sir. Sir, it is 1370.66.
Yeah, that is correct. So, shall I solve or shall I wait for someone that one more should answer?
Yeah, please solve this because I did not understand this.
Okay, fine. I'll go. Uh, who is that? Can you please tell the what is the formula name that if I'll ask? That is lambda. That we can get for Poisson distribution. Lambda is equal to
Confidence
NP.
interval.
Yeah. So that the question is given 1300 white blood cell counted per 1 ml of blood. Okay. So what we have to find out? Question is there. So that 95% of confidence. Don't worry about in this figure. Sometimes we have to use the chart or something. So I will tell directly value of t and all these things. Once you will go through the lecture of t test and all these things, once you will go to this formula that runs the test, so you will get to know that. For today, I will directly apply the formula and then I'll give the value for the 95% of the confidence upper limit. What is the value of t? Okay. And once you will go through the lecture in the coming module, so you will get to know that what are the tables we have available. T test for that one table will be there. For F test, we will be having some different table will be there. Okay. For upper and then lower limit, all these things. So don't worry for today.
What's
Confident.
the formula for this? Because I did not really get for this formula because I know
Wait.
T
I
test
will write it.
for
I will. There is a formula basically lambda is equal to L plus minus T root under L. So that is the L is that your white blood cell. That is the total. The T will be the 95% of that company's upper limit. What is the value of T that will get from the table? So this was all I was speaking that for this. For today only, I will just give the value. Once you will go in the upcoming module, so you will get to know that how we can see the table and then how we can get the for different confidence level will be the T different T value will get. Okay. So we have to find out the confidence upper limit for the patient true white blood cell count. So that we are going to use the formula, this one, that is the formula. Okay. So where T will be 1.96. From where we got that, what I was speaking, that the one table is there for any test, like T will be 1.96 for, this is for which one? 95% confidence interval. If we say the interval will change 99%, so the value will be 1.96, it's going to be 1.86 or something, it will change. So that you will be knowing once you will able to see that some that Fisher, this value will get the Fisher test, you might be knowing that Fisher test all the things. So from that they have dragged table for all tests. So don't worry for now. I will give the value directly for now. Okay, so we have the L value is equal to 1300, and then T value we have 1.96. So how we can get it? Lambda is equal to
Got it.
13,
Yeah, got it. Got it.
okay, 1.96 into 30. So 1300 plus minus 70.6688. So either that value will come to one mm, will come 129.31 or 1370.669 as a upper limit. So we can consider 1370.669. Okay. So this is, so if we take approximately the 3710 1370. So means for the 95% upper confidence limit, the patient true world that white blood count will be the 1371. Any doubt in this? For this T value, please bear for at least 2 week more. Then once the test will start, then we'll get to know that. We'll go to the next. What is the mode for the set of the data? 14, 13, and then 13, 16, 17, 14, 22. It is a simple basic statistic. There is no proof that is a probability. Only we have to find the mode. I already explained. Just anyone please explain. All the steps are already given. So it's like data set is given. The 14, 13, 18. Okay, the data sets are given like this: 13, 18, 13, 16, 17, 14, 22. So we want to know what is the mode. So first what we'll do, arrange the number. So 13, 13, 14, 14, 16, 17, 18, 20. So mode. What is the mode? Anyone please tell? It's like already told, the value which comes more often and mostly the distribution is centered around it. What do you mean like this? Can anyone please explain what is the mode? What is the difference between the mode and mean?
I mean, means the data which is coming more often, and mean means the average
Yeah.
of all the data.
Yeah, it's like we have to say like in the main, like we are taking the average of all the data, whether that is coming more often or less often. We are not care that much. But if we say the mode, like it's come more often, or that should be a like distribution is like centered around. So means the in the data, like
Is
if you
this
say the given
condition
data,
of centering, is this
what
condition of centering is this condition of centered around essential? Because that is why the answer of 13 that is why the answer of 13 will be wrong and 14 will be right over here.
Yeah, if we take the average, if we somewhere it will go, so it will be around the 14 or 15 something. So if we take the 13, so it will be a skew. Maybe the positive skewed or negative skewed. We'll once we check the testing. So it should be like it should be a centered. That it should be not the bias around the more less number, or either bias around the more number. Okay, now
Oh,
Yeah, so this then we know that 13 and 14 are the more frequently, but the thing is that 14 is around the center. So that's why we can say the mode for this data set we have the 14. Okay. In a normal distribution curve, 3 sigma represent what percentage of the area? Anyone know the normal distribution? All the thing. Actually, this question is coming from the third and fourth module, but still I will discuss like this again. The if you say the tables and all the things, we'll get to know that.
99,
Yeah,
it's 99.7, right?
yeah,
99.7, right?
yes, yes.
Yeah.
Any doubt is there in this? Like,
Can you elaborate how we have come to this? Yeah.
uh, this I can elaborate now, but it will better if you go through the lecture first. If I'll explain some normal distribution before that curve, or either we'll explain about the sigma and all the things. So I have to explain from the starting itself. So it will take again some half an hour at least, or some 20 minutes.
In
Uh,
the, sir, in the lecture, they have told that it will be of about 99% only in plus or minus 3 sigma.
okay.
But here 99.7, 99.8 is there.
That
But in the lecture,
you
it's certainly told.
if you will if the thing like if
And in
I'll
lecture, 99.7% was told. I have
okay.
written 99.7 in lecture only.
Okay, yeah, because if you see once you will see the curve and then their distribution, like so you will get to know that when z value and all the things will come in the picture. So this is all about like that is why the answer will 99.7 only. Yes, sir, only. So I'll go to that, just go to the normal distribution itself, and then how we are seeing the graph for the different z and all that only. So this will come so once you will see the lecture. Okay,
Yeah, okay.
we'll go for the last question. In a standardized normal distribution, what is the area between z is equal to -2 to z is equal to +2? Again, the one-tailed and two-tailed. So let's explain. Actually, we are already running out of time. Already 8:02. Shall we stop for this and then we'll discuss this last two question in the upcoming live session?
Yes, sir. Yes, sir.
Sure, no problem.
Just 1 minute.
Yes, sir.
Yes, sir. Thank you, sir.
Okay, thank you for joining. And if anyone
Sir,
have the doubt, please
Thank you,
just
sir.
ask.
sir, can we get this PPT, whatever which have been solved?
Yeah, this PPT will be given. I will be uploading. The public link will be there. So in the coming session, I will put the link in the chat box.
Okay.
And
And
also,
sir, when exam registration will be around February 16th, it was been said.
Okay.
Before it must be done.
Yeah.
Registration is already open. No,
Re-
registration is
No,
already
no, not
open. I have
registration
registered.
for it. No,
Exam
no, no.
registration.
Sorry, ma'am. For not for registration. For the exam. When is the last date to apply for the exam? I've been
And
looking
Yeah,
for
that
it.
is what. That is only I'm saying.
Okay.
Yeah, it's already open. I have registered for the exam.
yeah, actually, for that course registration already that is
It's still
also
last
open.
is
I think it
Last
is
date.
still
till
last date is 29th, I think.
15th February.
I think
So they
15th
have
February
extended.
will be there. For exam registration, it will be 15th February, but for course registration, it's still 29.
Okay. And also, Asjad, it would be helpful more if you can share us some practice questions also from your end, like for beginners like
Yes.
me. We can practice more and go for a better assignment
Yeah,
question
yeah,
ask.
yeah, yeah, yeah. Yeah, sure. Kada, I will try my best to give that, and I will definitely I'll keep some that PPT and all the things, and
Okay, and
that
that book
practice question.
also, And that book also you are going to share, I think,
Yeah, I will
the
for the coming the session. I will be taking some reference. That is a book reference that is going to use for the biostatistics, and then website that you can follow that is as a reference, and then some practice question. I will try to make it, and then I'll put in the that PPT itself, or either I will be giving another thing. Okay, under PPT itself.
Thank you. Thank you so
Okay.
much.
Thanks, sir.
Okay, thank you so much for listening me, and thank you. Hopefully, we will see in the next week.
Thank you, sir. Thank you so
Thank you.
much.
I think tomorrow also it is there, no?
I think another TA will be there, not me. I'll be coming in
Yeah.
that coming week, Friday, 6 to 8.
Okay, okay, yeah.
Thank you. You can all leave.